is going on page 63. When we are done, we're going to talk about logarithms. So exponentials and logarithms are very much related to each other. So we reviewed graphing of exponentials yesterday. We are going to review the very basics of logarithms today. This is not brand new to you. This is totally an Algebra 2 concept, especially the very basics. But I'm going to start by showing you a quick little video that explains logarithms pretty well.
How does the difference between 0.0000000000398 and 0.00000000398 cause one to have red eyes after swimming? To answer this, we first need a way of dealing with rather small numbers, or in some cases extremely large numbers. This leads us to the concept of logarithms. Well, what are logarithms? Let's take the base number b and raise it to a power p, like 2 to the third power, and have it equal a number n. We get an exponential equation, b raised to the p power equals n. In our example, that'd be 2 raised to the third power equals 8. The exponent p is said to be the logarithm of the number n. Most of the time, this will be written log base b of the number equals p to the power. This is starting to sound a bit confusing with all the variables. So let's show this with an example. What is the value of log base 10 of 10,000? The same question could be asked using exponents. 10 raised to what power is 10,000? Well, 10 to the fourth is 10,000. So log base 10 of 10,000 must equal 4. This example can also be completed very simply on a scientific calculator. Log base 10 is used so frequently in the sciences that it has the honor of having its own button on most calculators. If the calculator will figure out logs for me, why study them? Just a quick reminder, the log button only computes logarithms of base 10. What if you want to go into computer science and need to understand base 2? So what is log base 2 of 64? In other words, 2 raised to what power is 64? Well, use your fingers. 2, 4, 8, 16, 32, 64. So log base 2 of 64 must equal 6. So what does this have to do with my eyes turning red in some swimming pools and not others? Well, it leads us into an interesting use of logarithms in chemistry, finding the pH of water samples. pH tells us how acidic or basic a sample is and can be calculated with the formula pH equals negative log base 10 of the hydrogen ion concentration, or H+. We can find the pH of water samples with hydrogen ion concentration of 0.00000000398 and 0.00000000398 quickly on a calculator. Punch negative log of each of those numbers, and you'll see the pHs are 7.4 and 8.4. Since the tears in our eyes have a pH of about 7.4, the H+ concentration of 0.70398 will feel nice on your eyes, but the pH of 8.4 will make you feel itchy and red. It's easy to remember logarithms. Log base b of some number n equals p by repeating the base raised to what power equals the number. The base raised to what power equals the number. The base raised to what power equals the number. So now we know logarithms are very powerful when dealing with extremely small or large numbers. Logarithms can even be used instead of eye drops after swimming.
Okay, so that's a basics of why we need logarithms, how they work, how they are related to exponentials. So let's look at this mathematically. So if you recall, when you changed a log to an exponential, now they did log base b of n equals p, but remember, the letters don't matter. It's where they are and what they do that matters. But we read this as log base b of a equals x. So if I want to change this to the exponential form, the base of the log is the base of the exponential. So the base of the log here is b, the base of the exponential is b. So this becomes b, and you go around the equal sign. B to the x equals a. B to the x power equals a. Okay? That's how you rewrite them, and then most of the time it's easier to deal with it in exponential form if you're having to solve it without a calculator. All right, common logarithm. So a common logarithm is if we have a base 10, okay, and the video referred to that. So log base 10 of x, you will never actually write it as log base 10. It would just be log of x That's kind of like we don't ever write x to the first power. It's just x. It's the same kind of thing. Okay. Any other base, you have to actually have the base there. All right, so let's just convert a few. We're going to go from log form to exponential form. So log base 7 of 49 equals 2. So we're not solving anything, like it's giving us a true statement and we're just rewriting it. So the base of log is 7. We're going to take it to the second power. That will equal 49. 7 to the second power equals 49. True statement. That makes a whole lot more sense to you than log base 7 of 49 equaling 2, but you can convert it to make it make sense. All right, on number 2, what's the base? 10. We're going to take it to the third power. That gives us 1,000. 10 to the third power equals 1,000. True statement. So here the base is 9. We take 9 to the 3/2 power equals 27. Okay, so the 3/2 power is like 3 times 1/2. How would I rewrite 9 to the 1/2 power? What's a different way to say that? No, if I just want if I'm just talking about 9 to the 1/2 power, what's another way to write that? 9 to the 1/2 power. No. It's what? Square root. That is the square root of 9. Gotta know what your exponents do. Okay, so here, this is like, another way to write this would be the square root of 9 cubed. And when you have something like that, you can do whichever one you want first. You can cube it, or you can take the square root of it first. I think taking the square root of it first would be easier. Square root of 9 is 3. 3 cubed is 27. So that's why 9 to the 3/2 power gives you 27. Okay, and then 4 to the -3 power equals 1 over 64. Okay, the negative exponent will will give you the reciprocal of the base, but it's not, this doesn't give me a negative anything. Okay, everybody good with all that? So we got to know how to go from logs to exponents. We have to know how to go from exponentials to logs. So here, remember the base of the exponent is, that's why I turned it down. The base of the exponential is the base of the log. So this is going to be log base 3. Log base 3, it goes around like that, of 1 over 81 equals -4. Okay, so 3 to the 4th is 81. That negative makes it 1 over 81, and that's why this log statement here is true. Okay. So 8 to the 0 power equals 1. Do you agree with that? Yes, so this becomes log base 8 of 1 equals 0. So if I change this to 5 to the 0 power, would I still get 1? So that means log base 5 of 1 equals 0. If I change this to 3 to the 0 power, I still get 1, right? So log base 3 of 1 equals 0. So what do you think about log of any base of 1? What's it going to give you? 0. Okay, here, this is, I'm going to go around in a circle again. So log base 10, I don't write the 10, it's just log. Log of 1/10 equals -1. And then here I'd have log base 12 of 2 square roots of 3 equals 1/2. What's another way to write 12 to the 1/2 power? Square root of 12, and the square root of 12 is 2 square roots of 3. That's why this works. Okay, we understand the formatting there? Okay, so on those we weren't solving for anything, we were just writing them down. Okay, so now we're going to actually evaluate some things. So we're going to rewrite this in exponential form and use our knowledge of exponents. So I'm going to set this equal to x. Since I have to actually solve, I'm evaluating, I'd like to have a little equation. So this is going to give me 6 to the x power equals 36. So what does x have to equal? 2. Okay. So some of them are going to be that simple, but we're going to start writing them in a different form because they're not all going to just spit out an answer that easily. So I'm going to say this is equal to x. So that means here I have 2 to the x power equals 128. So we can figure that one out kind of the same way, but want to rewrite these with common bases. 2 to the x equals 2 to the something, and I have to figure out 128 is 2 to what. So again, use your fingers. 2, 4, 8, 16, 32, 64, 128, right? So it's 2 to the 7th. And since 2 to the x equals 2 to the 7th, x equals 7. All right, so I'm going to set this equal to x. I'm going to get 3 to the x power equals 1 over 27. I'm going to get a common base of 3. Tell me something other than the number of the exponent that goes here. What does it have to be? Negative. Okay, so that negative gets the 27 into the numerator, and then 3 to what power gives me 27? 3. Okay, so I get x equals negative 3. Here, I'm going to set this equal to x. So I get 9 to the x power equals 1. I need a common base. 9. So 9 to what power gives me 1? 0. So that means x equals 0. So you may have thought, oh, I didn't really need to get common bases to figure those out. We're about to do some where you really kind of do. All right. So here again, I'm going to set this equal to x. What's the base here? 10. So I get 10 to the x equals 1 over 100. That means 10 to the x equals 10. I know it needs to be a negative. A negative what? 2. Negative 2. So x equals negative 2. All right. Set this equal to x. So I'm going to get 16 to the x power equals 2. So I'm thinking I can't use 16 as my common base, right? Need to use 2 as my common base. So if I have a common base of 2, this value is 2 to the first. Okay, I'm not changing the values of them. And then I'm going to have 2 to some number, I don't know what it is yet, times x. So 16 to what power gives you, I'm sorry, no. 2 to what power gives you 16?
Hello. Is this thing on? Not working. Oh, it is working. Hey, everybody, don't forget to take your attendance. Don't forget to check your doors. Have a good day.
Okay. 2, 4, 8, 16. It's 2 to the 4th. So 2 to the 4x equals 2 to the 1st. Right? So we get common bases. So now we can say that 4x equals 1. So x equals 1/4. 1/4 is the same as the 4th root. The 4th root of 16 is 2. That's my answer. Okay? Questions? All right. So here, set this equal to x. We get 16 to the x power equals 1 over 32. All right, well, I don't think I can use 16 or 32 as my common base. I know the square root of 16 is 4, but 4 times 4 is 16. 16 times 4 is not 32, so I can't use 4 as the base either. But I can use 2. So I'm going to use 2 as my base here. I've got something that goes before the x. 2 to what power gives me 16? 4. And then here, I know this exponent has to be negative. 2 to what power gives me 32? 5. So that means that I get 4x equals negative 5. X equals negative 5 over 4. We good? All right, so set this equal to x. 4 to the x power equals 128. So maybe I can use 4 as my base. 4 times 4 is 16. 16 times 4 is 64. 64 times 4 is not 128. So 4 cannot be my base. I'm going to have to use 2 as my bases. So this is going to be 2 to the 2x power. And then 2, 4, 8, 16, 32, 64, 128. That's 7. So 2x equals 7. Does x equal 3.5? No. Does it equal 3.5? No. 7 over 2. Yes. That's the only acceptable answer there. What questions you got? Anything? Okay, so on the video, they talked about the change of base a little bit. It did talk about the buttons on the calculator, that kind of thing. if we were going to actually, I mean, there are some that we're going to have to push the buttons on a calculator for, but it's not all about just being able to push it in the calculator, because the calculators don't only do base 10. Even the calculator they showed you, there's a way in there to get it to do other bases besides base 10, but sometimes you need to get it out of whatever base it's in. So even though this says to estimate or approximate it and basically push the buttons, we're not going to, because that's not what we're trying to get at right now. But if I do have log base b of anything, and this b is anything other than 10, we can change the base. We can change the base by doing a common log in the numerator and denominator. So basically log base 10, so we don't put the base there. The base of the log, whatever that is, goes in the bottom. The base goes in the bottom. The other one goes in the top. So it's really easy to remember. You just split it up, base goes in the bottom. Because here's why we have to do this. If I set this equal to x, like we just did all those other ones, right? And I rewrote it, I would get 20 to the x power equals 4, which is totally a true statement. But I can't split that into common bases with exponents I just know and can kind of figure out by hand. Does that make sense to you? Like it's going to be some weird number that may not come out nicely at all. So although this isn't wrong, that doesn't help me here. Instead, I would have to change the base. That means I'm going to get a log in the numerator, a log in the denominator. The base goes in the bottom, and this goes in the top. And no, you cannot reduce the 4 and the 20, because it's not log times 4, it's log of 4 and log of 20. Okay? We good with that? Questions you got? Okay. All right. Then, let's see, this one, we'll just go ahead and change the base. So I'm going to get a log and a log. What goes in the bottom? 6, and the top goes 2. Okay, it's that easy. I don't think we need to do 23 and 24. So let's skip down to the natural logarithm. So moving forward, so this is a pre-calculus class. Regardless of whether or not you ever choose to take calculus, you're in a pre-calculus class. It prepares you for calculus. That's the whole point. And I will tell you, the natural logs, this is what we use moving forward. You still need to understand the basic logs. But natural logs, that's really all you're going to use after this class for mathematics-wise. I'm not saying you wouldn't use it in a science class or something else. But if I have base e, it's called a natural logarithm. So log base e, you will never see it written like this, but that's basically what it means. So if my base is e, our new favorite number from yesterday, you write it as a natural log. That is a lowercase l and a lowercase n. It is not a capital I. Okay, you need to stress that very much. Natural log, like log natural, this is backwards. Natural log, and I don't put the base. This implies that the base is e. It just looks like that, natural log of x. So if I'm going to rewrite these, if I have natural log of x, my base is e. Take it to that exponent just like the rest. So e to the 4th equals x. I do not expect you to be able to estimate what e to the 4th is. It's e to the 4th. I do expect you to estimate what e is. E is about what? 2.7. E to the negative 1 power is about what? 0.4. 0.367. I mean, but the 0.4 is all we really need right now. Okay, so then this one right here, we would take e to the x power, and that equals 10. So that's taking it from the natural log to the exponential, and now we can take the exponential and turn it into the log. So it's just like before. This is the base, and it goes around like that. So I don't write log base e. Log base e is natural log. So the natural log of 50 is equal to x. And then this last one, we would have the natural log of what? X equals 0.5. Okay. What questions we got? Anything? Awesome.